Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.7, Approximate Integrals, part 2. We're going to do a huge example. Approximate the integral from 0 to 1 of e to the x squared dx with n equal 10 using A, the midpoint rule, B, the trapezoidal rule, C, the Simpson rule, D, which estimation has the least error, E, how to pick, and if we want the best estimation to be accurate within 0.001. It's a pretty small error. Okay, let's take a look at how we do A. In part A, the integral from 0 to 1 e to the x squared dx is approximately. In the midpoint rule, we have b minus a over n, that is the width, multiplied to a bunch of different length. That's f of, well, if we divide this into 10 intervals, the first interval will be between 0 and 0.1. So it's going to be a half of 0 plus 0.1. And the next one is going to be half of 0.1 plus 0.2. And all the way until the last one. F of half of 0.9 plus 1. Okay, b minus a is 1, so it's 1 over 10. This one is f of 0.05 plus f of 0.15 plus plus f of 0.95. Function is e to the x squared, so 1/10 of e to the 0.05 square plus e to the 0.15 square plus e to the 0.25 square plus e to the 0.35 square plus e to the 0.45 square plus e to the 0.55 square plus e to the 0.65 square plus e to the 0.75 square plus e to the 0.85 square plus e to the 0.95 square. Wow, I'm done. Plug this in the calculator and ta-da! We have a number that's approximately 1.460393. B. Let's take a look at the trapezoidal rule. Integral 0 to 1 e to the x squared dx, approximately half of the width, b minus a over n, multiplied to f of 0 plus 2 times f of 0.1 plus plus 2 times f of 0.9 plus f of 1. Yay, do the substitution. 1 over 2 times 1 over 10. F of 0 e to the power 0 plus 2 times e to the power 0.1 square plus 2e to the power 0.2 square plus 2 times e to the power 0.3 square plus 2e 0.4 square plus 2e 0.5 square plus 2e 0.6 square plus 2e 0.7 square plus 2e 0.8 square plus 2e 0.9 square. And the last one is plus e to the power 1. Yay! Plug this in the calculator and we have 1.467175 approximately. A little overestimate compared to the midpoint rule. Last one is, yay, let's take a look at the Simpson rule. C, integral 0 to 1 e to the x squared dx is approximately, Simpson is 1/3 of the width b minus a over n. In here, f0 plus 4 f of 0.1 plus 2 f of 0.2 plus dot 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 plus 2 f of 0.8 plus 4 f of 0.9 plus f of 1. Let's plug it in. 1/3 times 1/10. And in here we have a e to the power 0 plus 4 e 0.1 square plus 2e 0.2 square plus 4e 0.3 square plus 2e 0.4 square plus 4e 0.5 square plus 2e 0.6 square plus 4e 0.7 square plus 2e 0.8 square plus 4e 0.9 square plus e to the power 1. Ta-da! Plug this in the calculator and we get a number approximately equal to 1.462681. Wow, that's crazy, but it does get the job done. Yay! So it looks like that the Simpson rule gives us a number that is in between the midpoint rule and the trapezoidal rule. Now let's do D. Which estimation has the least error? Before we take a look at the error, it is best if we get the derivative of fx equal e to the x squared up to the fourth derivative. So f prime x is 2x e to the x squared. F prime prime x is 4x squared plus 2 e to the x squared. F prime 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 x is 8x to the power 3 plus 12x e to the x squared. Fourth derivative of x is 16x to the fourth plus 48 x squared plus 12e to the x squared. We know that x is between 0 and 1, which means that x squared is less than or equal to 1. F prime prime x is 4x squared plus 2 e to the power x squared. So this is less than or equal to 4 plus 2 e, which is 6e, and this number is k here. Now, we have k, we have ab, and we have n. Now we are ready to figure out the error using the midpoint sum or midpoint rule. Is use the formula k times b minus a to the power 3 over 24n squared. That is e times 1 over 24 times 10 squared. And that is approximately 0.0068. Okay. For the error using the trapezoidal rule, is pretty similar. K b minus a to the power 3 over 12n squared, which is e times 1 over 12 times 10 squared. And that is approximately 0.0136. To do the error using the Simpson rule, we have to consider the fourth derivative. The fourth derivative is 16x to the 4 plus 48x squared plus 12 e to the x squared. And this is less than or equal to 16 plus 48 plus 12e, which is 76e. Okay, so now the error using the Simpson rule is less than or equal to k b minus a to the power 5 over 180 n to the 4th. So that is 76e times 1 over 180 multiplied by 10 to the 4. And it's approximately 0.0001115. Oh, look at the error from the Simpson rule here. It's pretty small. Smallest error. So this is the least error here. Meaning that the Simpson rule is the best rule to use in the estimation of this integral. We have one more. How should we pick n so that the error is within 0.001 or the approximation is accurately within 0.001? So that would be E. Now to do this problem, consider what we did up here. We know K is 76E. Now use the formula ES less than or equal to 76E over 180 n to the 4. This is at maximum 0.0001. So we can see that n to the 4 is 76e over 180 multiplied by 0.0001, which give us that n, you just have to take the fourth root of each. Is greater than or equal to 18.4. And because n is an even number, n must equal to 20. Yay! As you can see, the bigger n is, the smaller the error is. Well, as you can also see, computation by hand is pretty clunky. There is a website that can help you to do the calculation pretty quick. And there's a nice website here. It helps you to do the Trapezoidal Rule, right? The Simpson Rule, the Midpoint Sum, right? Midpoint Rule. So we're just gonna take a look at one here. Simpson Rule for a function. The function is 1 over not e to the power x squared. Integrate from 0 to 1. And ta-da! We did 10. So let's calculate. Oh man, look at the solution here. It's pretty cool. It gives you the detailed solution. And look at the answer. Yay, that is what we have. Using the calculator. Pretty cool, huh? Everything here is done by a set of coding. So you can get the code by searching the internet, and that is why coding or programming is very important, because we don't do this by hand. If you do this by hand and get large, it is very tedious. Thank you for watching. I hope you find the content useful. Please like, subscribe, help the channel grow. I will see you in the next video.